Greetings, Dennis Daniels here. This is a response to a very interesting video found here, Algorithm of Thoughts. And I went ahead and I tried some of the code. And this code is actually more showing Python threading than any kind of agent-oriented prime number finder, I think. I frankly don't understand the code, but I built this demonstration here to explore whether or not having multiple threads. Let me see if I can show you that. Yeah, show you that in the process of using right here, evaluate the agent, and this agent would then go ahead and find primes, hopefully faster than just with one agent. I use the Miller-Rabin function because the original, I used Miller-Rabin prime number function to identify, and you can see I've already done 2 runs here. So the first run I used an agent, 10 agents, and it took 1.82 seconds, and then I used just 1 agent and it took less than a second. Why? I do not know. So let's go ahead and just I'll use 1,000 again, because otherwise it's just not going to work, or maybe it will work. All right, so interestingly, this time it took 1.11 seconds. That might be something on the Streamlit side, so can't use that as any kind of found 93 prime numbers. Now actually, let's check if we bump this up to 10. And let's see what happens. Again, we're going to run it for 1,000 and see how long it takes. All right, so this time, and actually this one, it took 1.93 seconds, which is slightly longer, only slightly. And it only found 90 prime numbers. So it's very curious how different the output is. And obviously we can ramp this up to a much bigger number, like 30. I don't think we're going to see any difference. 1.8, okay, so this says it took 1.94 seconds, although 1.84 seconds, I'm not quite sure why is the difference here. And now not a big difference in time, in fact, versus 30 versus 10. It's fascinating. I don't know why multi-threading would have such a big difference in the results as well. 136 prime numbers when 30 agents are running. So let's bump this up to 50 and see how many prime numbers it finds this time. All right, so 147 prime numbers now. So clearly something is amiss in the algorithm itself. And the difference in time is also significant. There's, you would think if I'm running 30 agents, this would be faster, but it's not. All right, the code, I'll share the link. I'll put the link to the Streamlit. You can check out the code on GitHub and play with it yourself. Big thanks out to this guy, Richard Aragon, for spurring on this this quest to determine agency and threading. If this video is interesting for you, please click the like, subscribe, and if you try this code out yourself, please let me know. Thank you for watching, and happy computing.